Right, so where are we? All right, so we're back to ultimately we're still back to the idea of gravity existing, right? And if you're
Yeah.
going to claim that I need to have an alternative or whatever, I'm going to say, well, there is an alternative, but you refuse to accept it because you say
Well,
that it lacks vector.
yes.
But the vector.
Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy, and welcome to the fourth episode of the debate between Anthony Riley and Craig from Fight the Flat Earth, where we analyze the techniques of a flat Earth debate. Hey folks, this is Bob the Science Guy, and greetings from Northern Michigan. Today we're going to have another look at the debate, if you want to call it that, between Fight the Flat Earth and Anthony Riley. Now, the rules are going to be the same for this episode, and that is that every time Anthony Riley says, snap the wand of Newton or some variation of that, you have to take a drink. Now, in honor of Mr. Riley's determination that density was actually a force, that drink is going to have to be a multi-layered tequila sunrise. So let's cue up the music and get this dumpster fire started.
The vector comes from the density of the relative densities of the objects that are in question. That's
Right.
where the
But
vector
my,
comes
my
from.
problem with that is that what is causing those relative densities? Why are they deciding to sit in that in that structure? Why,
Right.
when you drop the cherry tomato in that, would it drop down to level 5?
Because do you agree that it can't maintain two places at once? It can only take one place.
I would say that it would have to have a reason to decide not to be in one place.
Yeah, it's called disequilibrium. So if its value is not equal to the medium it's in, it's going to displace relative to the medium it's currently sat in. And if that means it displaces up or down, in this context, I'll use it loosely, but up or down because of its disequilibrium, that then allows it to find its position, its relative position relative to the medium it's in. So what?
Well, while this is a slightly different meaning of disequilibrium, I thought it was quite appropriate because every time I listen to Anthony, I tend to get nauseated. Now, he's attempting to put in a fifth basic force of the universe here. That is the force of disequilibrium, which apparently can move objects all on its own in whatever universe he's thinking of. Unfortunately, that's not really what happens in the universe the rest of us live in.
So what you're claiming is, well, you need to provide a model. Well, I can provide a model, and I know that you disagree with me and refuse it because it lacks a vector. But by virtue of the density disparity between the two mediums, the two objects in question, that is the vector. That's where it comes from. So, I mean,
Okay, Anthony, I'm going to go ahead and stop you right there. Simply because two objects have different densities and you put them next to each other does not mean that they're going to move. If that was the case, the pen and the mouse on my table would change positions depending on which side of the mouse my pen was on. And that just doesn't happen. Something has to move things. And in the case of density, what moves them is gravity. That more dense objects are stronger attracted by gravity and sink below the less dense objects which float on top of them. And you can do that for as many layers as you wish. And if you take gravity out of the equation, you drop it in free fall, which brings it to zero gravity. You put it in the vomit comet, which brings it to microgravity as well. Or you have it up at the ISS. Things don't change based on density. They don't rise. The density towers don't work. Bubbles don't rise in water. I put a demonstration of that up where Chris Hadfield wrung out a wet washcloth in the International Space Station, and you see the bubbles floating in the middle of that water tube. So learn a little bit about density, all right? That's all I'm going to say. And learn a little bit about buoyancy, which involves gravity.
so I mean, yeah, you can disagree with me on that, but at least acknowledge that there is an explanation for it.
No, I can't, because the explanation is flawed, and it's
So,
so
so hang
flawed
on.
at such a basic level. I've had the same argument with Flat Earth Jesus, and you're not quite as wrong as Flat Earth Jesus with things, because I'm pretty sure you don't think the moon was dug out of the Grand Canyon by giants, do you?
I don't know where the moon come from. It could have done.
Do you know flat Earth? Do you know of flat Earth Jesus?
No, I don't. But
Oh my goodness! Right, and I've had the density argument with him as well, and the way that he tried to describe it to me was the reason there's a vector is because of everything. The air pressure above it is all pushing down, creating the density.
It's just relative. As far as I can see, it's relative to the medium it's in. But the thing is, though, if you're going to disagree with me, right, and you're not even going to credit me with an alternative explanation, right, how can I accept your rejection of the Einsteinian point, which is it snaps the wand in two, blah, 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 and it's
He said it. Take a drink of the density tower known as the tequila sunrise.
And it's literally the current science. If you're going to dismiss mine...
Because I've explained to you why it's wrong, and I can explain to you why your explanation of a vector is wrong.
But you're not... but all right, I'll agree that you disagree with me on the vector point, but I don't agree with you that you can dismiss the citation that I've got on screen now from Scientific American, demonstrating the current science as accepted by the scientific community, right? You disagree with that, and I say that you're pissing in the face of all the science. So you're denying science.
What about you're obviously going to disagree with the fact we went to the moon, but the Newtonian physics is what we use to send rockets up. Our understanding of F equals gm1m2 over r squared, it is what we use to be able to calculate why things move.
I'll give you the moon landings are real. I'm not interested.
Okay, Anthony, stop right there. You give us that the moon landings were real. That means that we had men land on the moon. You know what else we did? We took pictures of the nice round Earth, just like that one, and like that one. The debate is over, Anthony. You just gave up. But because I like watching you make a fool of yourself, I'll let you continue.
It's real. I'm not interested in talking about the moon landings. What I do want to talk about is what you mentioned on non-sec recently. I've got a clip from non-sec where you were talking about you measuring the distance to the moon, right?
I've got the details of that here. I knew you were going to
ask great. Right, so what you actually said, I'm going to play it for the benefit of the audience. You should hear this because it seems to be passing through, which is great. I'll stop it. I'll provide commentary at the end of it, and then I'll invite you to explain what you're referring to, because I'm going to call bullshit on it for a couple of reasons, which, based on your explanation, we'll have a conversation about why this is bullshit. But let's hear what you say.
Distance to the sun. I didn't. Wait, let me explain. When I figured out the distance to the sun, I didn't use any figures that anyone had told me. I looked at Venus through a telescope. I figured out the parallax of Venus. Using that, you can figure out how far away Venus is. And then using simple trigonometry, you can figure out how far away the sun is. I didn't get anyone else's information on that. I did that with simply with a lens inside a telescope, right? So, and we know these things work.
All right, so first off, when did you do this?
A long time ago, like before I ever had a YouTube channel or anything.
Was this academically, or was it done for your own leisure, or what was the circumstances?
Kind of curiosity, to be honest, because I'd seen it being described and I wanted to see if it could be done. Where I said I didn't use anyone else's data, that's not particularly true, because when you work out the parallax, you have to take it from two different places.
Okay, so, hang on, stop. Let's not jump past this point. I want to know when you did it. Whereabouts were you in life? Had you just bought your first house? When did this happen?
It was a long, probably before I joined the Navy, to be honest.
Roughly what kind of year would that be?
2000-ish? I can't remember.
So what you're saying is that you had a telescope and you observed the parallax of the transit of Venus and calculated the parallax based on the transit of Venus, right?
Well, all right, to calculate the distance to the sun by way of the transit of Venus, you need two observers, and they trace the path of Venus across the disk of the sun. You can then calculate the parallax based on the distance the observers are apart, and it's just simple math from that. It's nothing that any high school kid couldn't handle. But the reality is this line of questioning has absolutely nothing to do with determining the transit of Venus or the distance to the sun. What Anthony's doing is trying to call out Craig as a liar. Craig, this is 2019. The transit of Venus that's in question here was in 2004. He said it was in the early 2000s. Anthony is trying to get him to pin this date down from memory and using that as a basis to say that he never did it. Now, mind you, if he really was interested in this, all he had to do was ask Craig, how did you do it? And the reason that that's important is, you may not necessarily remember the exact date you made the observation. I mean, it was 15 years ago. But if you don't know how to do it, then clearly you're talking out of your tail. Now, I think the better reason that he didn't pursue that is he doesn't know how to do it himself. And so he wouldn't know whether or not Craig was telling the truth or not because he's pretty clueless. Now, personally, I would have just said, well, it was in the early 2000s at the last transit of Venus, and here's how I did it. But we're going back and forth, with one guy saying you're a liar, the other saying, no, I'm not, for the next 20 minutes, and I think we can just kind of discard that. If you want to go look at the 20-minute exchange, feel free. It's on Craig's channel. There'll be a link in the description of this video.
That's fantastic. However, he was living in Paris and he determined the shape of Saturn. I'll give you this link in the side chat in a sec. He says Huygens wanted to give the sizes of the objects. In this case, he's talking about the Earth, the Sun, and Venus. He wanted to give the sizes of these objects relative to the size of the Earth. So that's the Kepler's law, third law on interplanetary motion. He knows the relative sizes.
Anthony, do you even know what Kepler's third law of interplanetary motion is? What does it have to do with size? What does it have to do with mass? Let me give you a little refresher on Kepler's laws, since you certainly don't have any clue as to what they are, Anthony. The first law says that the orbit of a planet is an ellipse, and the sun, or the central mass, is at one of the two foci of that ellipse. The second law says that if you look at the area of the ellipse that's swept out over a period of time by the orbit of the planet, that area will be constant for the same period of time at any stage in its orbit. Kepler's third law says that if you look at the length of the year, or the one full orbit of a planet about its sun, you can determine the distance from that planet to the sun. None of these laws have anything to do with the shape, size, or mass of the objects in orbit. Anthony, stop confabulating and crack a book and maybe learn something. Perhaps if you ask Craig, he will educate you, but quite frankly, I doubt he'll bother.
He knows the relative distances. I agree. He knows relative because he's got Kepler. He knows the relative distances of the planets, but in order to convert his angular measurements into Earth diameters, he needed to find the distance from the Earth to the Sun in Earth diameters. And this is where it gets a little bit sticky. Huygens solved the problem with an assumption. He assumed, or he supposed, that the planet Venus, aside from the fact that we can't even prove that it's physically a planet, it just appears to be a light in the sky, but he assumes that the planet Venus was the same size as Earth.
And so it is. What a lucky guess. Well, what if it wasn't, Anthony? Would we have perhaps had to revise our figures when more data came in? Isn't that part of science? Since you're a minibus driver, or at least you used to be before court, and you apparently have no training whatsoever in science, let me give you an example that you may be able to understand if you think real hard on it. If you look out the window of your minivan as you're driving down the road, you see objects going by you. Having driven for a number of years, we can kind of look out the window and say, hey, I think I'm going about 50 kilometers an hour. Now, if you look down at your speedometer and it says you're doing 57 or 32 or 78, you can revise your estimate, can you not? And come up with a better answer. The same thing is being done with Venus. They assumed, based on many, many things, that it was about the size of Earth. And they went with that assumption. And if that changed, they would change the assumption a little bit. And they'd still be able to use the same math. They'd just have to change a few things. That's called learning and getting better information.
Well, that means that you're calculating your angular size based on the Earth being a fixed size, which you believe is based on Aristophanes' calculations with sticks in the grounds, which let's just give him the benefit of the doubt and say that he's correct, even though Neil deGrasse says that it works out both ways.
Hey, Anthony, how about giving old Eratosthenes a little break here? Did you get off your butt on March 20th and go out and do it yourself? I did. And so did BlueMarbleScience down in Tennessee. And you know something? We got the same figures. Not only roughly the same figures as each other, but roughly the same figures as Eratosthenes. And you know what else we did? We proved the Earth could not be flat in the process because we used 2 points.
Both ways. If you're going to base your assumption that Venus is the same size as Earth, which itself was based on the assumption that it was spherical at the time, which, bearing in mind, Aristophanes was 250 years before Christ, and I'd love to know how he knew that it was spherical before Christ, given that the most he could do was wander about the Mediterranean Sea on a camel. I'd love to know how they knew it was spherical. But anyway.
Anthony, did you just do an ad hom on Eratosthenes because he rode a camel at a time a camel was pretty good transportation? Do you notice, too, how he tried to cloud the waters as well by saying that he didn't even know if Venus was a real planet versus a light in the sky because that's all he can see? It's a spherical planet, dude. It rotates. It has an atmosphere, as you can see by the clouds. An atmosphere next to a vacuum.
But anyway, if he's going to assume Venus to be the same size as Earth, that then gives him a size for him to then use basic trigonometry. Now, if you don't assume that it's the same size as Earth, you haven't got the ability to use basic trigonometry as you claim, because you need to know its actual size, Craig. You can't
I will grant you that I have to assume that Venus is roughly the same size as Earth to do this, all right? I will give that to you.
So that's kind of fallacious, though, isn't it? Because what if it's not?
Well, if it's not, then your numbers are wrong, Anthony. When you get a better size on Venus, your numbers will get better. As it just so happens, Venus is about the size of Earth, so the numbers were on. That was dumb luck. God protects fools and children. What can I say?
Well, it's been shown to be that. Now, thing is, when you start with things, you kind of have to start with an assumption. And then...
No, you don't. That's not what science says. You can make the prediction and then you have to test it. But if you're going to make the assumption to start with and then stand by it, then that's a bit of a problem because it's based on a presupposition, right?
Right. Yeah, but okay. Yes.
Okay, Anthony, let's just kind of take this to a little better example that you can understand. Based on your actions and your reasoning here, I'm going to make an assumption that your IQ is about 80. Now, I can listen to you a little bit more and get a better feel for what your IQ is, and I may revise it up to 84 or down to 76. You never know. Now, one of these days you may actually take an IQ test, and I'll find out your IQ, say, is 92. Well, then I'll reassess my assessment and put you up to a 92. That's kind of the way it works with Venus.
Yes, I was going with the accepted knowledge of Venus being approximately the same size as Earth. But this has been shown to be the case since it was an assumption.
Really? So
yeah,
where's the proof?
We have satellites orbiting it. We've
No,
actually gone and physically measured it and stuff. I mean, obviously you're going to ignore the fact that space is real and satellites are out there. But
Craig, we don't have satellites orbiting anything.
That's a massive assumption.
No, we don't have. I'm not assuming. I'm definitely not assuming.
See, I say we do.
This is the best evidence.
We can use the satellites for data. So you can deny space travel all you want, but
Craig, listen. I'm presenting to my audience now. Craig, I'm presenting to my audience now the best available evidence that we've got for satellites. The one fell in the Amazon rainforest, I think it was, or Bolivia or Chile or wherever it was. And it's best described as a balloon with a big massive canopy on it and what looks like scaffolding with a couple of car batteries, right? That's the best evidence that we've got for satellites orbiting anything. So I'm going to ask...
That's not the best evidence. The best evidence is that you can actually see a lot of them.
Oh, dear God. We can see satellites in orbit. There's videos of them from private individuals all over YouTube. You can go to freaking launch facilities and see them on static display. He's got a balloon in some country that he can't even name because he didn't even bother. He just found a picture of a balloon. And with that, despite all the evidence to the contrary, he's just making the pronouncement that there are no satellites. We have weather satellites we see on the news every single night. Yet he can't even admit that these things are real, despite the fact he has admitted we went to the moon. Guys, we all need a drink after that one, so just take a moment, pound it, make yourself another, and then we'll try and struggle through the rest of this. We've got another 36 minutes.
That you can actually track them. In fact, I could go on my app right now and find exactly where they are above me. Understanding how GPS works.
Yeah, but hang on.
It's only possible with satellites. If we're going to argue satellites, Anthony, I can do that all day.
Sure, but if you're going to argue spectroscopy to prove satellites, I can argue that all day too and prove that it proves absolutely nothing.
Seriously, Anthony, what does spectroscopy have to do with getting a pair of binoculars and looking at satellites? This is a typical technique that Anthony likes to use, folks, and that is Craig's cornered him here on the satellites. I mean, easily cornered him. Now, he's trying to change the subject to try and get out of it. He's done this several times in this debate.
I wouldn't argue spectroscopy. I'd argue physical observations.
Yeah,
I
that's
would argue
spectroscopy.
data that gives us stuff that we're able to do that wouldn't be possible if there weren't satellites in space.
Right, but the satellites that you're claiming are supposed to be constructs that are launched by a rocket that have ended up orbiting the planet, and I'm saying that you can't prove what they are. You believe that the lights in the sky that you're watching are satellites, but you can't prove it. You're using spectroscopy to prove a tangible object was launched at some point by a rocket. I say no.
I've seen rocket launches. Red's Rhetoric has been in actually physically recorded rocket launches. He watched the Discover satellite being put into space. And I've seen raw footage of that, unedited.
So when you say, did you just say the Discover satellite, the Epic?
Yeah.
So you're going to say now that Red's Rhetoric watched, oh no, not that one. It's that one. You're going to say that Red's Rhetoric watched the Epic Discover satellite that's supposed to have taken the imagery from Earth, from Lagrange 1 of the moon transiting the Earth. Is that what you're telling me?
Yeah, he recorded that being put into space.
Right, but there's no proof whatsoever that the crappy footage that he presented, or the Epic Discover footage that was presented by NASA, is anything other than CGI. If you think that that's credible evidence...
Red's Rhetoric doesn't do CGI. I've seen his raw footage, like from the memory card of his camera.
Right, but do you understand what the affirming the consequent formal logical fallacy is? If rocket launches into space and then we see satellite taking crappy CGI footage, therefore satellites must
Anthony,
exist.
do you know what the genetic fallacy is? Because you're committing that a lot here. I haven't seen it, so it can't be real.
No, it's not that I haven't seen it. It's the point that you guys can't prove that there's a tin can orbiting anything up there, but you claim that it's true.
We can, because the data is only possible if it's out there. For instance,
so you don't think data can be manipulated?
8, and I can tell you about some observations that would only be possible if there was a satellite in space.
No, but you don't understand how software algorithms can work to demonstrate a point that you believe is real data, but simply
I most certainly do. Like, there are certain things that cannot be done unless we're imaging things from space.
Like what?
Like in 2015, there was a wildfire on the Mongolia-China border, right?
Right.
The only way this would have been seen is with something high up enough up to see it.
And you don't think they could fake that?
The only thing that picked it up was the Himawari 8. And using the data from the Himawari 8, they were able to track and predict the path of the wildfire and save lives. That wouldn't have been possible without the data from Himawari 8.
So you're going to claim Himawari saved people's lives because it was a satellite orbit. So, right, all right. So then that begs the question, well, what is the Himawari? Is it a satellite orbiting in space?
Yes.
And how do you prove that?
Because of the data that it gives us every 10 minutes.
That's not no. That's not proof. If that's
it is, because it's not possible to do any other way.
No, it's not proof, mate. Right. First off,
let's not say proof. It's evidence that it is a satellite in space. Evidence that corroborates with all the other evidence of satellites in space.
Do you think?
If we want to talk about satellites, tell me how GPS works.
No, hang on. Do you think that the photographs, and I use that word very loosely, from Himawari are real photographs?
Yeah, they are. They're real-time images.
No, they're not. The composites, they've got to be stitched together.
No. Himawari doesn't do composites. Himawari images the entire Earth.
No, you're wrong, mate. You're wrong.
No, I'm not. Himawari doesn't do composites. Himawari images the entire side of the Earth that it's on.
Yeah, Himawari takes the whole Earth at once, and there's a couple of examples, including liftoff of the rocket. Now, are y'all noticing that all Anthony is doing is just saying, no, sticking his fingers in his ear? He has no evidence that he is presenting. Craig is presenting evidence up the wazoo. Any of you can go to the internet and see these images. These images are used day to day for weather forecasting, and that is what the satellite was put there in the first place to do. Now, I'm kind of going through this as it goes. I happened to look at it a little earlier, but I'm thinking that this conversation is just going to disintegrate into this is what it is, no it's not. This is what it is, here's the evidence, no it's not. And I don't think that I'm going to waste your time with that. Let me watch it a little bit longer, and if we have anything more of note, I'm going to go ahead and include it.
Can somebody in chat give me a citation for the Himawari image citation? Because if you're going to claim that they're not composites, I'm going to call bullshit and I'll demonstrate it, although I don't have it immediately to hand. But I'm pretty sure somebody in my chat will come up with the citation that shows that they are composites. Right, let's move forward. I'll present it. Oh, hang on. Hang on. So somebody's giving me a link here. What I'll do is I'll present this on screen. Come on, Gleam. Oh, shit. Hang on. Stop. The chat's going too fast. Right, let's see if I can get it. Meteorological Satellite Center. I'm not sure. I'm just trusting what Gleam's giving me here, so let's have a look. Himawari 8 and 9 will have a dedicated meteorological mission. Hopefully this is going to be showing the bit that they are composites.
Right. Okay, now let's when it says composite in this way, what it's meaning is it's a composite of the spectrums of light, not composite of different sections put together. The Himawari images in like infrared, in ultraviolet, and green, blue, red, and it puts those images together. It
by definition makes it a composite image, right? Do you not agree with that?
Well, in the same way that your any imaging device can basically be called a composite because it takes the data and puts it together.
Right. So it is a composite then.
Not a composite in the same way as the 2012 Blue Marble.
Right, I've got it on screen right now. The words are: color images will be derived by compositing 3 visible bands: blue, green, red.
Yeah,
now,
but it's still one real-time image.
Yeah, but it's still a composite though, isn't it? But the point is, let's just say that they're a real picture. They're not, but I'll just agree that for this point that they're real pictures. Where's the picture taken from?
Where's the picture taken from?
Yeah.
The geostationary point above Japan.
So why do they have to put them together in bands?
Because that's the Himawari 8 sees more than we can. It doesn't just image in one thing. They want to have more information than just our eyes can see. So they image it in different spectrums, put that together so that we can see more information.
I'm just being told play the flipping video. No, play the flipping video. Gleam, is this right? So he's asking me to play the video.
Oh, Gleam, he's a troll.
I'm trying. Yeah, but he's got the citation that I asked for. So whether he's a troll or not, on this one point, he's presented the information that I want. Because I knew it was out there somewhere, I just didn't know it. I'm trying to press the video, Gleam, but for some reason it's not working.
But do you agree that the composite that they're talking about there is different to the composite of, say, the 2012 Blue Marble, which was literally different pictures stitched together?
I'm not sure, to be honest with you.
Because when you look at the 2012 Blue Marble, it was, I think, taken over 16 hours, about 8,000 passes of the Earth, really close, and then it had to stitch those images together. Whereas the Himawari 8 takes one full image in 3 different spectrums and puts those together.
What I'm showing on screen now, I don't know if you can see it or not. Basically, it's the banding.
To your stream 2 secs.
I'm showing the banding that I'm referring to.
Yeah.
And after this point, I'm prepared to drop this point because I want to go back to the distance to the sun nonsense that you were talking about before. Because to be honest, I don't even accept Himawari as a valid argument, let alone a credible one. But this is the point. If this is supposed to be the imaging capture process that Himawari uses, I'm going to say that this is not actually going. It's not actually in the physical distance that they claim it's in, because it would be able to take one picture at this distance and it wouldn't have to band it.
Well, it's a lot of data there, Anthony. But
this is not a render. Together. This is not a concept. This is not a consequence of rendering. This is the way they capture it.
It's because there's so much data.
One picture that we're giving you the benefit of the doubt, saying that it's a picture.
Yeah.
Well, he's going to go on to another subject now, and I'll probably make one more just to finish this up. There's not that much left. But let's just take a moment and have a look at this beautiful blue marble photo from Apollo 17, a single shot of the entire half of the Earth from 1972. This is Bob the Science Guy. Thank you for tuning in. I'll sign out, and like I said, we'll probably do one more on Craig and Anthony. But I think most of the quality stuff is behind us, and I think it's going to deteriorate into a "you're a liar, no I'm not" type argument. But I'll see. Please take a moment to like and subscribe to my channel.
This rabbit hole